In this section here, we're taking a look at the three different forms of the quadratic equation. We've already talked about two of them, standard form and vertex form, a little bit, so they should be just a little bit of review. And then we're going to also add in the zeros or factored form. The more proper term for it is factored form, but you will hear zeros form, and I kind of refer to those two terms interchangeably. Standard form, we recall ax squared plus bx plus c is our equation, and then the vertex form is a times x minus h squared plus k. Remember, standard form and vertex form. Standard form is just kind of what we have as our general equation, and then vertex form gives us the actual vertex of the parabola by looking at the values. The third form that we often see in quadratics that we find very useful is the zeros or factored form. And we'll talk more about factoring in later lessons. But factored form here, a times x minus r times x minus s. So we have the two values in brackets. Notice the minuses, just like in the vertex form, so they're going to behave very similarly, becoming the opposite. Each of these forms provides some different information for us, and depending on our situation, different ones are more useful than others. So in all three cases, you see that they all start with an a value, and the a value, no matter what, that value in front always does the same thing. Sometimes it won't always be in front, sometimes they rearrange it a little bit, but in general it's in front. But that a value that you're multiplying everything by, or the x squared by, does a couple things. The main focus is that if it's greater than 0, if it's a positive number, it makes sure that the graph opens upwards. And then if it's less than 0 or it's a negative number, the graph's opening downwards. That's the key thing that we take away and we'll be using with that. Now, in terms of what each of the specific forms give that's different, in the case of standard form, we're looking at the c value at the end there. So just that c value at the end of the equation. And that c value, what it does is tells us the y-intercept, or where the graph crosses the y-axis. So it's that point where it's going to cross the y-axis. It tells us the actual number that is. And that's the key value that we get out of the standard form, is the direction of opening and that where the y-intercept is. The vertex form, when we work with that, a vertex form gives us the vertex. And the vertex is in the form of hk, h and k, h being the value in the brackets and k being the value outside the brackets. Remember, the h flips, the sign of the h flips to, so if it's negative in the brackets, it's positive out of the brackets. If it's positive in the brackets, it's negative out of the brackets. So it flips when we actually want to look at the h value itself. So h is a left or right shift. And then k is, so it tells us how much it shifts left or right, positive or negative. And then k tells us how much it shifts up or down, positive or negative. And then again, hk being our vertex. So we've looked at those in the first unit. Hopefully you got some familiarity with that, or you can go back and look at that content from the first unit. The new one here is the factored form of the quadratic equation. So with the factored form of the quadratic equation, we have the x-intercepts of the parabola. And so this tells us where the graph is going to cross the x-axis. And the r and the s are what tell us where the graph is going to cross the x-axis. So the r value and the s value, again, just like the h value, it's always opposite sign. So minus r becomes positive r, minus s becomes positive s when we flip it out. And they just tell us the points where the graph crosses the x-axis. Note, it doesn't have to be right at one's not always going to be positive or negative. They could both be positive. They could both be negative. It doesn't matter. And we'll take a look at some examples of working with some of this stuff in the following questions. So in this first question here, we just want to graph y equals negative 3x squared minus 6x plus 4. Determine the direction of opening. What's the vertex? Is it a maximum or a minimum? And then is the what's the y-intercept here. So a couple of these, or sorry, all three of these questions we can answer without actually graphing them. So we'll actually answer these questions first, then we'll do the graph. So the direction of opening. Well, the direction of opening, is it up or down? That's based on our a value. So we look at our a value and it's negative. The a value in front of the x squared here is negative. That means this opens down. And the vertex, is it a maximum or minimum? Well, if the graph's opening down, so you're going to have a graph looking like this. I don't know where exactly it'll be on the grid, but it's a graph looking like this. That means the vertex is going to be the highest possible value, and so it's going to be the maximum value. So it's a max value. And then what's the y-intercept? Where does this graph cross the y-axis? Well, we know that one as well, because it's the c value there. So we just look at the c value of 4. That's our y-intercept. So our y-intercept is at 4. So we can answer those three questions just looking at that equation. And then if we want to graph it, we just use our table of values and we plot it. And so we actually know that 0 is 4 because that's where the y-intercept is. So we know there's a point here at 4. And that's right from the equation. Now from here, we got to figure out the rest of the points. So we would sub in our x values each time, remember. So I'll do 1 here full out. So we got -3, and then the x squared from the equation above. So the x squared, so -3 times -3 squared minus 6 times -3 plus 4. In this situation, there's two -3's just because it happens to be that the first a value is a -3 in the equation. But we work that out. So we have -3 times -3 squared minus 6 times -3 plus 4. And so that's going to get us a total of -5. So there's our point for -3. And then we just continue down that table. -3 times -2 squared minus 6 times -2. And so we're going to get 4. Then we plug in the -1. And we get 7. We'd already done the 0. Notice the pattern here. I bet you the 1 is going to be a -3 because it's matching here. And then the last two, what do we got here? That's -20, and then the -3, or sorry, the +3. Going to be -41. So these last 2 points are not fitting on the graph, but that's okay. We got our 1 point here already graphed. A -1 and 7 is going to be about right here. -2 and 4 going to be right here. So you see that symmetrical nature of the graph already. 1 and -3. And -3 and -3. So that's going to be -3 and 1 right there in the middle of that square. And then one more will fit, I think. No, that's all that'll fit. So that's all that'll fit, and then it gets way down low. So just connect those. And there we got ourselves a parabola. Again, as we said before, you don't have to do this. If you want to do the table and use a tool like Desmos to do the table, you can do that as well. And then just copy out the points from Desmos. Perfectly fine. But just working through the process here. Okay, let's move on. Take a look at the next one. So again, in this case, we're going to do a quick sketch of the parabola, and then we have a couple questions to answer. Some of these, again, we can answer without doing much of anything. We can just look at the equation. So let's start answering as many questions as we can before we actually graph it, or draw the sketch of it, sorry. I got -1/2 x plus 6 squared minus 4. What's the direction of opening? Looking at the a value. And I apologize for the blurriness. That keeps happening. So direction of opening, it's negative again, just like the one above. So that means this opens down. And then where's the vertex? Well, this is vertex form. The vertex is at HK. Remember, H is the opposite sign. So -6 and -4 is our vertex. Is it a maximum or minimum? So again, just like above, because it's opening down, it's going to be a maximum value. The axis of symmetry, remember, that's the line that cuts the parabola right in half. So if I look at this one, the axis of symmetry is the line that goes right down the middle here. And it's always matching up with the x value of the vertex. So we look here at the x value of our vertex, -6. Our axis of symmetry is x equals -6. And it's always x equals the x value of the vertex. The last part is the y-intercept. And if we look just quickly above again, remember the y-intercept occurs when the x value is 0. This doesn't give it directly in the formula, in the equation, but we can calculate that pretty quick. All we got to do is f at 0. So the y-intercept is always at f at 0. We could even calculate it here. We could set x equal to 0 in this equation and would have got it. But it comes in, the equation gives it to us anyways. So we're going to do it here. F at 0 equals -1/2 times 0 plus 6 squared minus 4. And we just calculate that. So we got -1/2. And again, if you want to type that in your calculator, it's just -1 divided by 2 times 6 squared. Let me do that. Half of 6 squared minus 4. So it's going to be 14, I think. Here, just double check. Oh, no, wait, that's a negative. Yeah, negative, sorry. No, 14's there, 22. So f at 0 is 22, -22. So that is our y-intercept, -22. So we calculate, whenever you have to calculate the y-intercept, all you're doing, putting x equal to 0 and solving for the y-intercept. Now this one has to sketch it, so we can do a quick little sketch here at the side. And we got some key information that we can use to help us out. We know the vertex is -6 and 4, so that's maybe somewhere over here, -6 and -4. It's opening downwards. And we also know, if I extend it past here a little bit, that this point where it crosses is at -22, because that's the y-intercept. So we got a few pieces of information there that helped us do a quick little sketch of what that graph might look like. Again, when we're sketching, we're not being exact. When we're graphing, we plot the exact points, but when we're sketching, we just do it approximate. Okay, moving on. Now we're going to look at the new one. So most of that should have been somewhat review-ish from first unit, but this stuff here a little bit new. Working with the 0 form or factored form. So we got You don't explicitly see the x squared, and in a couple lessons we'll take a look at where that x squared actually comes from in this, but the fact that we'd have two x's that are involved in multiplication is going to create that x squared. So just take it for granted for now, and then when we get to the section later on, you'll see why that is if you don't recall from grade 10. So the first question does say, what's the direction of opening? So we look, and there is no number out front of this one. And if we look back at our forms, it was a, and then the x minus r, x minus x. So there's no a value out front. If there's nothing out front, it's not 0, it's 1. So we assume a is 1. So it's a positive 1 out front here. So this is technically a positive 1. So the direction of opening, positive, means it opens up. And what are the x-intercepts? Well, the x-intercepts are going to be taken right from the equation. The 2 and the negative 6 are where we're looking. And just like the h value in the vertex form, these are just opposite. So the x-intercepts are negative 2 and positive 6. So negative 2 and positive 6. So now the next part asks where the vertex is. And here I'm going to do a little sketch of this graph first to help us out, because it'll give us a little bit of information that'll help you understand where I'm just magically making this up, which is not magic, it's math. So if I do a quick sketch here, I know the x-intercepts is going to cross the x-axis at negative 2, and then at 6, maybe here. And I know it's opening up. So knowing what we do about parabolas, we know, I'm going to try and focus this, parabolas are symmetrical. So right in between these 2 points will be the vertex. If I go back to this example, that axis of symmetry, the x value of the vertex, is right in between those 2 points. So to find the vertex, we just have to find the middle of these 2 points. So how do you find the middle? Same process every time. The x value of the vertex equals the 2 numbers added together and divided by 2. So in our case, negative 2 plus 6 divided by 2. Negative 2 plus 6 is 4. 4 divided by 2 is 2. So it works out in this case that the middle of those 2 values is 2. So we know there's an axis of symmetry about right here at 2. And so somewhere up here is going to be the y value of the vertex. How do we find that? We just plug 2 into our equation. So we have f at 2 equals x, sorry, not x, but 2 plus 2. 2 plus 2 times 2 minus 6. So we just calculate that. 2 plus 2 is 4. 2 minus 6 is negative 4. 4 times negative 4 is going to be negative 16. So there's our vertex at 2 and negative 16. So again, opening up, that makes sense. Somewhere down here at 2 and negative 16 is the vertex. And then we can draw our parabola sketch. There's our quick sketch of it. We got our zeros, we got our or x-intercepts, and we got our vertex. Is it a maximum or minimum? Well, from the graph, we can see that the vertex is the lowest value, so it's a minimum. And then we want to know the y-intercept. So we want to know what this value is right here. And again, like before, we just sub in 0 for x. F at 0 equals 0 plus 2 times 0 minus 6. So we end up with 2 times negative 6. And when we do 2 times negative 6, we get negative 12. So that's our y-intercept, negative 12. That would be this point right here, negative 12. So there you have a zeros or factored form of the quadratic equation. Again, we can get our direction of opening right from the a value. We can get our x-intercepts from these two values. Get that centered a little more. So from these two values, just set them opposite signs. So again, positive 2 became negative 2, negative 6 became positive 6. That happens every time we have something x plus or minus in a bracket. Once we know those two values, we know because of the fact that a parabola, a quadratic graph, is symmetrical, that the x value of the vertex is going to be right in the middle of those two. So this is what we do every time. Add those two values up, divide by 2. That gives us the x value. Once we know the x value, we can find the y value by subbing it in to the equation there. And in this case, we got negative 16. And then again, when we get to the case of finding things like the y-intercept, it's just a matter of subbing in 0. So just a couple of practice questions with stating some zeros here. And then we'll be done this fairly long video. I know it's a little bit longer, a little more content, by getting us started in this section. So focus. Here we go. So we got the function g at x equals 4 times x plus 3, x minus 2. So our zeros, we look at these two values here, and we just flip the signs. And again, I really apologize for this crazy zooming and focus issue. I'm going to try and figure that out eventually here for the next video. But our zeros would just be negative 3 and positive 2. So just the opposite. In the next case, little tricky, we don't have two sets of brackets. Technically we could. The one value you could add or subtract to x. So if you were to wanting to put a set of brackets here with this x, the one value you can add or subtract and not change it is you could add 0. So this is technically x plus 0. Focus. Wow, it does not want to focus for me. There we go. Little bit better. Okay, I'm gonna have to zoom right in on this. It's really struggling here with me. Okay, so x plus 0, x plus 1. What are our zeros? Well, in this case, it'd be 0 and negative 1. I hope you can see that there. Okay. And then for our last one, we got plus 6, we got minus 6. So this one becomes negative 6. This one becomes positive 6. We have negative 6 and 6 as our zeros. So we're not worried about the value up front in terms of finding the zeros. That's our direction of opening, our a value. But those bracket terms, you just flip the signs to get your two x-intercepts where it's going to cross the x-axis. And if it's just a plain old x by itself, like this one, it's just 0. I guess I showed there's, yeah, that should be close and good. Okay, so try out the practice questions on this one.